Alright, so today we're going to be doing the notes for 14.1. It's called Understanding Geometric Sequences. And so the learning target for today's notes is to determine the pattern in and state the common ratio for a geometric sequence. We're going to start with a couple different vocabulary words. An arithmetic sequence is a number pattern where the same number is added or subtracted each time. And that number that you add or subtract each time to get the next number in the pattern is called the common difference, which is generally abbreviated by the letter D. So let's say, for an example, our number pattern was 2, and then 5, and then 8, and then 11, and then the dot 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 means that it keeps going. We can look at the difference between each of these numbers to figure out what number we're either adding or subtracting each time. This list is getting bigger, so we know we're adding by a number. And let's see, to get from 2 to 5 we add 3, to get from 5 to 8 we add 3, and to get from 8 to 11 we add 3. So we would say for that list the common difference is 3. In the next definition, a geometric sequence is defined as being a number pattern where the same number is multiplied by each time. And so the pattern's going to be a little bit different in this one because you're not adding a number to the previous number to get the next number in the list, you're multiplying. That number that you multiply by is called the common ratio, and it's generally abbreviated or represented by the letter R. So in our notes today, these are going to be the kind of sequences that we practice. To give you an example of that, let's say you also start with the number 2, but then the next number in the list is the number 8, and then the next number in the list is the number 32, and then the next number in the list is 128, and then the list keeps going. So this list is also getting bigger. It's being multiplied by a whole number, and so to figure out what the common ratio is, we just need to look at the pattern of increase. So to make a 2 turn into an 8, you multiply by 4. To make an 8 turn into a 32, you multiply by 4. And to make a 32 turn into 128, you also multiply by 4. So the common ratio for this geometric sequence would be the number 4. If the numbers started bigger and were getting smaller, sometimes your common ratio can be a fraction, but in this case it was a whole number. So in example number 1, it wants us to describe the pattern in each sequence, state the common ratio, and then find the next 3 numbers in the sequence. So in the first one, it's going from positive 5 to negative 5 to positive 5 to negative 5. So the sign is changing back and forth. What's happening is it's being multiplied by a negative 1, and that's what's going to switch the sign back and forth. So to state the common ratio, we can say that R is equal to negative 1 because the R is the number that it's being multiplied by each time. It also asks us to find the next 3 numbers in the sequence. So to find the next 3 numbers, I would just keep the pattern going. It would switch back to positive 5, then back to negative 5, then back to positive 5. And so we'll do the same thing for the next 2 problems in this section. For the next one, you're probably going to want to grab a calculator so that you can continue the pattern. On this one, it's also being multiplied. The numbers are getting bigger. It's being multiplied by a 3. And you can check between any of these 2 numbers to figure out that any of these 4 numbers to figure out that it's being multiplied by a 3. 5 times 3 gives you 15, 15 times 3 gives you 45, and 45 times 3 gives you 135. So that would mean that the common ratio on this one's positive 3. And then to find the next 3 numbers in the list, you would take the last number that they gave you and times it by 3. So the next number in the list is going to be 405. And then you would times that number by 3. So the next number after that is going to be 1,215. And then times that number by 3. And you get 3645. So to get each number in the list, you're multiplying each number before it by the common ratio. So on this last one, the pattern is that it's being multiplied by 2. Because each number times 2 gives you the next number in the list. So my common ratio is positive 2. And then to find the next 3 numbers in the list, I would take the last one that they gave me, which was 24, and I would times that one by 2, so I would get 48. And then I times this one by 2, which gives me 96. And then I times that one by 2, which gives me 192. And so you could keep this pattern going to figure out as many numbers in a row as you're being asked to find. In question number 2, we're performing a similar task. It says to describe the pattern in each sequence, state the common ratio, and then find the indicated term in each sequence. So the only thing that will be different is that in this last step, instead of listing out the next 3 numbers in the list, we're just going to find the 7th number. We're just going to find the 6th number that would be in the list. So in the first list, they give you 1, 2, 3, 4 numbers. It starts with a 2, and then it goes to 4, and then 8, and then 16. So the pattern in this one is that it's being multiplied by 2, which means my common ratio is 2. To find the 7th number in the list, we only know the recursive format of these sequences. So to find the 7th number in the list, they gave you the first one, the second one, the third one, and the fourth one. So 16 times 2 would give you 32. That would be the 5th number in the list. Times 2 would give you 64. That would be the 6th number in the list. And then times 2 would give you 128. And that's your answer to the question, because you didn't need to find all of them, except we did need to find all of them, because this is the only way we have of finding the 7th number or finding the 6th number in the list. Notice on the next one, the numbers are going down. The common ratio is defined as being the number that you multiply by each time to get the next number in the list. So even though these are cutting in, they're dividing by 2 to get from 100 to 50 to 25, etc., when we explain the common ratio, we can say that the pattern, when we describe the pattern, is that they're being divided by 2, but when we state the common ratio is always the number that you're multiplying by. So when you give the r equals, you have to say it's 1/2, because 100 times 1/2 gives you 50, 50 times 1/2 gives you 25, and so on. On this one, we're trying to find the 6th number in the list, so they gave me the first one, the second one, the third one, and the fourth one, and so to find the 5th one, I would do 12.5 times 1/2. So that's not the answer to the question, that's just the 5th number in the list. And then to get to the 6th number, I would multiply that number, and so it's 3.125. Something that I didn't mention about the common ratio is that if you want to, you can also write the common ratio as a decimal, but just remember, it's the number that you're multiplying by, not the number that you're dividing by. On letter C, they give us 4 numbers in the list. Notice that they're switching back and forth from positive to negative. You can ignore that for a second. To get from regular 2 to 6, you times by 3. To get from 6 to 18, you times by 3. And so on this one, the pattern is that it's being multiplied by 3, but not just by 3. It's being multiplied by -3, because the sign is switching each time. So my r would equal -3. And then they want me to find the 5th number in the list on this one. So I would take the 4th number, the last one that they gave me, 54, and I times that by -3. And so my answer for this question is -162. I only had to find 1 in this one because they just wanted me to find the 5th number in the list, and that was the next number. Question number 3 gives us a word problem that we can use a geometric sequence to help us figure out the answer to. It says a bungee jumper jumps from a bridge. The table shows the bungee jumper's height above the ground at the top of each bounce. The heights form a geometric sequence, and it wants us to figure out what the bungee jumper's height is at the top of the 5th bounce. Something that we haven't said in the notes so far, up above, in all of these problems, it was pretty easy to figure out the number that you were multiplying by, because it was either a whole number, a positive or negative whole number, or in the case of number 2b, it was a fraction, but 1/2 wasn't that hard of a fraction to figure out, because it's a fraction that we're used to seeing. In number 3, to figure out how a 200 turns into an 80 and how an 80 turns into 32, remember, you're trying to figure out the number that you're multiplying by. When it's hard to figure out the number that you're multiplying by, though, what you can do is you can work backwards and you can divide. So if you're not sure what fraction you times 200 by to turn it into 80, notice that I knew it was going to be a fraction, right, because the number's getting smaller. To figure out my r value, I can always take something besides the first number in the list. So like on this one, I could take the number 80, for example, and I can divide it by 200. So 80 divided by 200, you can do that in your calculator. You could write it as a fraction if you want to. So if you reduce it as a fraction, it reduces to 2/5. Or what most people will probably just do is they'll write it as a decimal. So 200 times 0.4 gives you 80. And then if you do 80 times 0.4 in your calculator, it gives you 32. So that's how you know it works for both of them. They want us to figure out what the bungee jumper's height is at the top of the 5th bounce. So the table did the first bounce, the second bounce, and the third bounce. To figure out the 5th bounce, we have to figure out the 4th bounce first. So it's kind of like we're going to make 2 extra rows in our table that weren't provided for us. We need to figure out the 4th one to figure out the 5th one. So I'll do 32 times 0.4. I'm just going to keep the geometric sequence going by multiplying by the common ratio again. So I'll take 32 and I'll times it by 0.4, and that gives me 12.8. And then I'll take 12.8 and times it by 0.4, and it'll give me 5.112. So at the top of the fifth bounce, the bungee jumper would be 5.12, it's height in feet, so 5.12 feet above the ground.